Hey kids, hope you're doing well. This video I'm going to introduce you to a very important idea, and it's called, or at least to the calculus, it's called continuity at a point. Continuity at a point. Okay? And so what we're going to do is we're going to say this. A function, which we're just going to call in general y equals f of x, right? Just some general function, is going to be continuous at some point. I'm going to name that point. We'll call it x equals c, right? So that's the point at which we're thinking about the continuity of this function. If three things happen. If and only if. Okay, and the three things that have to happen are, okay, number one, f of c has to exist, which means c has to be an element of the domain of that function. Right? There has to be a y value to which c is attached. Okay, the function has to exist at that point. Okay, so I call that the at condition, right? Something's got to be going on at that particular point. Number two, I call this the around condition, right? And the around condition is, what have we been talking about? That's right, the limit. So the limit as x is approaching c of that function f also has to exist, right? Which means that we can't have plus or minus infinity, right, as x is approaching that particular c value, right? We can't have the left and right hand limit disagreeing. We can't have an infinite oscillation. We can't have any crazy stuff. It has to be well behaved around c, right? So we have, so far, we have the function that exists at c, right? F of c exists. And then around c, a very small, tight neighborhood about c. The limit as x is approaching c has to exist. And now there's one more thing. Those two values have to be the same. And this is kind of wraps it all up, ties it up in a nice bow. So the function at c, right, has to be equal to the limit as x is approaching c, which means the behavior of the function around that particular point, c, has to be the same as or consistent with the behavior of the function at c. Okay? So these are the three things. All three have to be met in order for a function to be continuous at a point. Okay? If any one of these three things break down, then we have discontinuity. We have a function that's not continuous at that particular point. So let's look at an abstract problem, and then we'll look at a very tangible problem. So let's suppose momentarily that that's some function f, right? Okay, who knows what it is? Looks like a piecewise function. We've got a lot of stuff going on. Okay, so let's evaluate the continuity. So I would say consider or examine the continuity of this particular function. Okay, and I would say, okay, this function is continuous everywhere except, so the question is, where is it not continuous? Except dot 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 dot. Okay? And so my job now is to find the points at which this particular function is discontinuous. We have points of discontinuity. All right? And I'm looking at this particular function. I see, just my intuition tells me that, okay, there's something funky going on around 2, at 2. Everything else is cool. Everything's cool here. Oh, and then there's something funky going on around 3. Okay? So other than 2 and negative 3, it looks like, okay, everything's cool here. Nice flow. It's flowing. It's flowing. Oh, something kind of weird happens around negative 2. Okay? And then if you kind of continue past negative 2, everything's fine. It's flowing. It's flowing. Oh, that's cool. It's flowing. It's flowing. Oh, something weird is going on here too. Okay? So at 3, we got an issue. And then whoop, everything's fine after that. Okay, so here's what's going on. Okay, let's examine when x equals negative 2. Okay, because that is indeed a point of discontinuity. Okay, so at x equals 2, negative 2, the function is discontinuous. So y equals f of x is discontinuous. Another way of saying that would be x equals negative 2 is a point of discontinuity, and we can abbreviate that POD. Okay, so either the function is discontinuous at x equals -2, or x equals -2 is a POD, a point of discontinuity. So the question is why, right? Well, what happens at -2? Which one or more of these three things break down, right? And so all we need is one of these three things to break down to destroy continuity. And so I'm going to note that, okay, the function does exist at 2, a -2, right? Okay, -2 gets turned into 2, right? So -2 is part of the domain, so if I'm going through this algorithm, f of -2 exists. Check. Okay, well, let's move on to the limit. So it's well behaved at that point. It is defined at least at -2. How about the limit as x is going to -2? Uh-oh. So what's the problem with the limit? That's right. We have inconsistent left and right hand limit. So the limit as x is approaching -2 from the left of our function is 2. That's correct. The limit as x is approaching -2 of our function from the right of -2. Uh-oh, -1. Ruh-roh. Oh, that's not cool. So what does that mean? That means, therefore, the limit as x is approaching -2 of our function just does not exist, since the right-hand limit ain't equal to the left-hand limit. Okay? So to answer the question, where is it discontinuous, x equals -2 is a point of discontinuity since or because the limit does not exist as x is approaching -2. Okay? And again, the reason that we know the limit doesn't exist as x is approaching -2 is because the left and right don't agree. Okay? So that's one point of discontinuity for this function. What's another point of discontinuity? Yep, you guessed it, at x equals 3. Okay? So I'm running out of room here, but I'm going to go down. I'm going to see if I can lasso this little puppy. Oh, nope, the whole thing. And I'm going to copy it and put it down on the other page. And so let's look at another point of discontinuity. I'm going to paste. Oh, that worked great. Okay, so we're, again, discussing the continuity of this function. And note that at x equals 3, we got a little issue. Okay, so x equals 3 is a point of discontinuity. So why do you think that x equals 3 is a point of discontinuity? And again, to refresh your memory, if any one of these three things don't break down, then we have discontinuity at that point. So the function has to exist at that point, the limit has to exist at that point, and those two numbers have to be the same. Right? So what's going on at 3? Well, note that the limit as x is approaching 3 exists. From the left, 0. From the right of 3, 0. Right? So, kind of off to the side, I'm noting that the limit as x is going to 3 is great. Right? 0. Check. Also, I'm going to look at the function at 3. So here's my around behavior, limit as x is going to 3. How about at 3? Well, f of 3 is -1. Whoop. So f of 3 exists. So at 3 I have existence. Around 3 I have a limit. But what's the problem here? Yeah, that's right. They're not equal, right? The limit as x is going to 3 of our function just ain't equal to the function value at 3, right? The limit, of course, being 0. And yet the function at x equals 3 is -1. Oh boy, that's a bummer. Right? So we have inconsistency around and at the point. Okay? So for that function we have 2 points of discontinuities. At -2, we don't have a limit that exists. And at 3, the function value at 3, which is -1, is different from the limit as x is approaching 3. Okay? So going back to the definition of continuity, or our definition of continuity at a point, each of these three things has to happen in order for our function f to be continuous at a point. Okay? Here's what I want you to think about. Okay, we'll look at some tangible examples tomorrow. Question. Name a function, any function, that is continuous everywhere. What do you think that means? No question mark. It's a statement. What that means is, correct, that there are no points of discontinuities. No PODs. Okay? So come in with a specific function that is continuous everywhere. There are no issues. There are no points that are discontinuous. Okay? All of these three things happen at every point for that particular function. Okay? That's your question for class. Bring it. Try to think of it. Do what you can. I'll see you in class.